So today we shall start the next class, that is change of gene frequency due to selection. So this is one of the forces responsible for systematic process for change of gene frequency due to systematic process. So we have already covered the other two processes or other two forces which are responsible for change of gene frequency due to migration and mutation. After this, we shall see how the change of gene frequency taken place in a small population due to sampling, that is the dispersive process. So let us see how the gene frequency changes due to selection. So for this, we have to know the selection. What is selection? And there are different selection. In a nutshell, selection means increase the frequency of desirable genes in the population. Selection means increase the frequency of desirable genes in the population. Okay, that means the individuals which carrying the superior genes for any character, we have to select, and that is known as selection. Okay.
Yes, sir.
According to there are two definitions as defined by the Professor I.M. Lerner and Professor J. Luss. According to Professor I.M. Lerner, selection is the non-random differential reproduction of genotypes, and according to Professor J. Luss, selection is the differential reproductive rates of genotypes whereby some individuals tend to have more offspring than the others. What does it mean? So there is little bit difference or virtually no difference between the two definitions, because in case of I.M. Lerner says selection is the non-random differential reproduction of genotypes. So there are few terms. One is the non-random differential reproduction. What does it mean? That means here the not random, as we have said that is random means, what is the meaning of random? Random means that when the probability of every event is equal. The random meeting, the random meeting is the meeting of individuals in which each and every individuals of a particular sex has equal chance of meeting with any one individual of the opposite sex in a population. That is called random meeting. So when we restrict the random, that opposition word is non-random. So selection is the non-random. Okay, because we are selecting some individuals which are definitely better or carrying the superior genes among the individuals in the population. That's why you have to select, and we shall allow them to produce the progeny for the next generation. अब हम अलाउ नहीं करेंगे. कितना टाइम हो गया? 9:40 हो गया. So now, and according to J. Luss, the selection is the difference in reproduction rates. Naturally, each and every individuals are not equally fertile, are not equally viable. Those who are not viable, they will be perished at the early life, and those even the fertile, those who are producing the offspring, they are not equally fertile. So once the individuals are not equally fertile, naturally they will not contribute their offsprings in equal number to the next generation. That is the meaning. So now it is clear. So that is I.M. Lerner says selection is the non-random differential reproduction of genotypes, because the reproduction of genotypes is not random, is not equal for every genotype. And in the second, that is as per J. Luss, that is the all individuals do not contribute the equal number of offspring to the next generations, because some of the because of the difference in their fertility and viability. So individuals, so that they accordingly they will contribute different number of offspring to the next generation. So there are some terms is connected with this when we will see the change of gene frequency due to selection. Oh, sorry. First is the fitness. What is fitness? Fitness means the contribution of offspring to the next generations by an individual is called fitness of that individual. Fitness means it is this is not physically fit. So we have here fitness in terms of the contribution of offspring to the next generation. The individuals which contributes maximum number of offspring to the next generation will say that individual is more fit, and the individuals which contributes less number of offspring to the next generation will call it the less fit. And that means the individuals which contributes maximum number of offspring to the next generation will say that is the most favored genotype or the standard genotype. Okay, that most favored genotype or the standard genotype. This fitness is also known as adaptive value or selective value. Fitness is also known as adaptive value or selective value. कौन है? दूर है सुनंदिक? कहाँ थे? Now, if the difference of fitness are in any way associated with the presence or absence of a particular gene, then selection operates on that gene. Definitely, the fitness, that is contribution of offspring to the next generations, is not equal to each and every individual. That is must be due to the certain factors. That means that certain, which is that factor? That factor means certain gene is responsible for fertility of each and every individuals. Yeah, if that particular gene is responsible for fertility of the individuals, if selection operates against that gene, naturally the contribution of offspring by the individual also will vary. Now, when a gene is subject to selection, its frequency in the offspring will not remain the same as in parents. Naturally, that means selection out of the several factors, that is migration, mutation, selection, and selection is the most important factor which is responsible for change of gene frequency. So naturally, due to selection, when selection operates against a particular gene, definitely the frequency of that gene among the progeny will not be same to that of their parents. This is the meaning.
सर हिंदी में भी समझा दीजिए.
That means that all individuals are not equally fertile, na? Some individuals are fertile, some individuals are highly fertile, some individuals are less fertile. In the animal, you will see that if you see that suppose that pigs, pig is a litter bearing animal. Mice, guinea pigs, rabbits, these are litter bearing animals. So do you think all individuals, all animals are producing the equal number of progeny to the next generation? No. Even in case of the mice, if we say the litter size is 6 to 12, that means at one birth they will produce the 6 pup to 12 pups. कोई ने 6 pup जो जन्म दे सकता है, कोई 7, कोई 8, कोई 9, कोई 10, कोई 11, कोई 12. It means that सब जो फीमेल का the equal fertility नहीं है. Clear? Hello.
Yes sir, हो गया clear.
Next is the selection is a major force to cause the change of gene frequency. So selection changes gene frequency due to differences in fitness that I have already explained. And when all genotypes are equally fit, the population remains in Hardy-Weinberg equilibrium. Okay? If all individuals are equally fit, that means if all individuals or all genotypes contributes equal number of offspring to the next generations, and then we say the population is in Hardy-Weinberg equilibrium. That means gene frequency and genotype frequency tends to remain constant in subsequent generation. So this another term is the strength of selection. Strength of selection is expressed as the intensity of selection. That is, it is the proportional reduction in gametic contribution of a particular genotype in comparison to the standard genotype. I was talking about the standard genotype or the most favored genotype. That means genotypes which contributes the maximum number of offspring to the next generation is known as standard genotype or the most favored genotype. And contrary to this or in against this term, there is another term known as strength of selection or intensity of selection. What is this? This is the proportional reduction in gametic contribution of a particular genotype in comparison to the standard genotype. That means standard genotype मान लीजिए that contributes 100 offsprings to the next generation. Next in place of standard genotype, the other genotypes, how many offsprings are contributing to the next generation? That is and that is expressed as the coefficient of selection. The standard genotype means it is the most favored genotype which contributes the highest number of offspring to the next generation. So suppose the gametic contribution of the standard genotype is taken to be 1, then the contribution of the genotype against which selection operates is 1 minus S. So as we have said that coefficient of selection means the proportional reduction in gametic contribution of an offspring to the next generation. And suppose the coefficient of selection is expressed as S, so the gametic contribution of an individual in comparison to the standard genotype is 1 minus S, because the gametic contribution of the standard genotype is considered as 1 or 100%. So this expresses the fitness of the genotype in respect to the standard genotype. Okay? The fitness of the standard genotype is considered as 1. So the fitness of the other genotype whose coefficient of selection is S will be 1 minus S. Clear? Now one example is given. If coefficient of selection S of an individual is 0.1, then what will be its fitness? Its fitness will be 1 minus 0.1, because 1 is the fitness of the most favored genotype or the standard genotype. So the fitness of the genotype whose coefficient of selection is 0.1 will be 1 minus 0.1 is equal to 0.9, and which is equal to 90%. It means if the standard genotype contributes but produces 100 zygotes for the next generation, the genotypes against which selection operates, whose coefficient of selection is S, that is 0.1, that individual will contribute 90 zygotes in place of the 100 zygotes. Clear? Hello?
Yes, sir.
सर फिटनेस ज्यादा होगा तो सिलेक्शन ज्यादा होगा, तो फिर इसमें 1 माइनस एस क्यों कर रहे हैं?
और फिटनेस ज्यादा होगा मींस जो इंडिविजुअल का फिटनेस मैक्सिमम है तो उसको कंसीडर करते हैं स्टैंडर्ड जीनोटाइप, दैट मींस उसको 100% हम मान के चलते हैं। क्लियर?
सर इंटेंसिटी वाला एक बार और समझा दीजिए।
Intensity of selection or the strength of selection and the coefficient of selection all are equal. ठीक है ना?
जी।
Now here another term which comes, the degree of dominance. As we know, that is the term dominance is means the in a heterozygote the gene which is expressed itself is known as dominant genes, and the gene which is suppressed in presence of dominant gene is known as recessive gene. But here we say that is dominance in terms of the fitness, not in any other phenotypic character. ठीक है? It is the degree of dominance की बात है. That means suppose there are two locus, two alleles, A1 and A2 at a given locus. So and their fitness, in respect of fitness, the different degrees of dominance will be expressed as such. As we know, that is that no dominance is there, complete dominance is there, over dominance. These terms are there. These terms comes in the principles of genetics that you have already read. In case of complete dominance, that is the examples are the that is height of the plant height of the Pisum sativum. You know that tall is dominant over the dwarf, so that is the complete dominance. The even heterozygotes also show the equally tall than that of the homozygotes. So that is called complete dominance. So here in terms of the, you just think about it as in terms of fitness. So complete dominance means here you see, the kind of arrow. That is, I have placed the arrow at at the genotype A1 A1, A1 A2. So नीचे इसका नीचे ठीक नीचे देखो 1 means it is the most favored genotypes. That means its genetic gametic contribution is 100%. That means it produces 100 zygotes for the next generation. And in comparison to the genotypes against which selection operates, that is A2A2 genotypes, homozygous recessive, consider homozygous recessive, whose coefficient of selection is S, then its fitness is equal to 1 minus S. Clear? So this is the complete dominance. In case of no dominance means that is A1, A2 will be expression of A1, A2, that is heterozygotes will be in the midway between the two homozygotes, that is A1, A1 and A1, A2. Suppose A1, A1 individual, which is most favored genotype, whose genetic gametic contribution is 100% or 1. And in case of A2, A2 genotype, whose coefficient of selection is S, naturally its gametic contribution or the fitness is 1 minus S. And A1, A2 is in the midway between the two homozygotes, so its fitness is equal to 1 minus half S. Similarly, in case of the upward dominance, the heterozygotes are superior over the both the genotypes, both the homozygotes. That's why it is in the right hand side. You see in the extreme right hand side, A1, A2 genotype, his fitness is 1. Then suppose that is coefficient of selection for A1, A1 is S1 and for A2, A2 is S2. Then fitness of A1, A1 individual is 1 minus S1 and to that of A2, A2 is 1 minus S2. So how the change of gene frequency takes place? Now I have cited an example. The change of gene frequency due to selection under complete dominance and selection operates against a recessive genotype. Okay? But recessive gene, recessive genotype. So change of gene frequency due to selection under complete dominance. So I have shown you the three conditions. That is incomplete dominance, by no dominance, complete dominance, and overt dominance. So what will happen in case of the complete dominance? What will the change of gene frequency, or how the change of gene frequency takes place? That is, you see, I have shown you one table in which the three genotypes and their initial frequencies, or we can say HoD inverse frequencies, is given. So in the left hand side, see the particulars, and the right hand side, you see the genotypes, the A1, 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 A2, and A2, A2. Okay, A1, 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 A2, and A2, A2 genotypes. So initial frequencies is the frequency of the best proportion or HoD population. The frequency होता है, मैंने वही लिखे हैं. P square for A1, A1, for heterozygotes A1, A2, that is 2PQ, for A2, A2, that is Q square, and total frequency will be sum equal to 1. And the coefficient of selection means contribution of offspring to the next. Coefficient of selection means proportional reduction in gametic contribution. Proportional reduction in gametic contribution. There is no reduction in gametic contribution. That means there is A1, A1 and A1, A2. They are dominant. So they are the most favored genotype. They are the standard genotype. So their fitness is 100% or 1. So the coefficient of selection for A1, A1 is 0, and for A1, A2 is also considered as 0. And coefficient of selection for A2, A2 genotype is S. So what will be the fitness? Fitness for A1, A1 individual is 1 minus 0 is equal to 1, and to that of the A1, A2 is equal to 1 minus 0 is equal to 1, and to that of A2, A2 is equal to 1 minus S. Okay. Now what will be the gametic contribution? The gametic contribution of an individual is equal to the product of the fitness into its frequency. So the gametic contribution of A1 and A1 individual is equal to 1 into P square is equal to P square. To that of the A1, A2 is equal to 1 into 2PQ is equal to 2PQ. To that of A2, A2 is equal to 1 minus S into Q square, that is Q square into 1 minus S. If after simplification, the new total, this is the old total, that is 1, the total genotype frequency. The new genotype frequency will be equal to 1 minus S square. How it is derived, you see in the next slide. So that is, say, the total gravitic contribution, that is new genotype or new total, is equal to P square plus 2PQ plus Q square into 1 minus S. And after simplification, this is P square plus 2PQ plus Q square minus SQ square. You see that is P square plus 2PQ plus Q square. What is the value of this? Huh? Hello, students.
1.
1.
1, sir. 1.
That's why I have written 1 minus SQ square. Clear? Then the new gene frequency of A2. New gene frequency of A2 क्या होगा? पहले A2 का gene frequency parent population में क्या था? A2 का, we have considered the frequency of A2 as Q. So the new gene frequency in the after gametic contribution, what will be the frequency of A2? So suppose new gene frequency of A2 is equal to Q1. So Q1 is equal to, how it is estimated? That is, you know that P is equal to, the frequency of A1 is equal to P, small p is equal to capital P plus half h, and to that frequency of A2 is equal to Q is equal to 2 plus half h. Thus consider. So then the frequency of A2 gene is Q1 is equal to Q square plus half h. So Q square का क्या है magnitude? That is Q square into 1 minus S plus heterozygotes frequency कितना है? 2PQ. That is half into 2PQ. And the total new total कितना है? 1 minus SQ square. So this will be, after simplification, will be, that is Q square minus SQ square, and this half into 2PQ is equal to PQ divided by the new total, that is 1 minus SQ square. Again, the next step, Q square minus SQ square. Now here I have modified that P, substitute the value of P as 1 minus Q. So 1 minus Q into Q by new total, then Q square minus SQ square plus Q minus Q square. So so we have Q square and Q square, दोनों एक प्लस माइनस डिलीट हो जाएगा. So the क्या रहेगा? Q minus SQ square. So न्यूमरेटर में है Q minus SQ square. इसको एज इट इज रहना दीजिए, माइनस SQ square भी माइनस SQ square प्लस Q भी रह सकता, कोई दिक्कत नहीं है, by new total, that is 1 minus SQ square. So this is the new gene frequency of A2 after selection. So then what will be the change of gene frequency? The change of gene frequency will be Q1 minus Q. Q1 is the new gene frequency and Q is the frequency before selection. So the change of gene frequency resulting from the one generation of selection is delta Q. Delta Q is equal to Q1 minus Q by substituting the value of Q1. So delta Q is equal to 1 minus SQ square. ठीक है? By 1 minus SQ square minus Q. So this is within third bracket. This is the value of the magnitude of the Q1 and this is the Q. So after the simplification, you see, just follow the steps. That is Q minus SQ square minus Q into 1 minus SQ square upon 1 minus SQ square, and after simplification, you will see here minus SQ square into 1 minus Q by 1 minus SQ square. That means this is the change of gene frequency due to selection when under complete dominance conditions, when selection operates against the homozygous recessive genotype. So what will be the conclusion? That means the change of gene frequency under complete dominance depends upon the coefficient of selection S and the initial gene frequency Q. ठीक है ना? That there are two terms. in this equation. One is S, sorry, other is Q square. So S is the coefficient of selection. That is, what is coefficient of selection? It is the proportional reduction in gametic contribution of an individual. Q square, Q is equal to frequency, gene frequency of the A2 allele. So there are only two terms. So and the symbol is, see, the negative symbol, negative sign. So the effect of selection on gene frequency depends not only on the coefficient of selection or the intensity of selection S, but also on the initial gene frequency. And the negative sign indicates that the frequency of A2 gene has decreasing trend. Okay?
सर हमेशा जीन फ्रीक्वेंसी घटता जाएगा सर जनरेशन टू जनरेशन.
Yes, because A2 what we have considered, that is frequency of recessive gene. So जब सिलेक्शन करेंगे किसका करेंगे? इंडिविजुअल्स उसी का सिलेक्शन होगा जिसके अंदर सुपीरियर क्वालिटी जीन्स है, डोमिनेंट जीन्स है. तो डोमिनेंट जीन्स का फ्रीक्वेंसी बढ़ते जाएगा, रिसेसिव जीन्स का फ्रीक्वेंसी पॉपुलेशन में घटते जाएगा. क्लियर?
तो सर अगर हम डेल्टा पी निकालते हैं तो इसका जीन फ्रीक्वेंसी जनरेशन टू जनरेशन इंक्रीज करता रहेगा. अगर डेल्टा पी निकालेंगे तो सर, जैसे डेल्टा क्यू आप निकाले ना सर, रिसेसिव जीन का जीन फ्रीक्वेंसी निकाले ना, तो इसका जीन फ्रीक्वेंसी जनरेशन टू जनरेशन घट रहा है. तो उसी तरह अगर डेल्टा पी निकालेंगे तो उसका भी जीन फ्रीक्वेंसी जनरेशन टू जनरेशन इंक्रीज करेगा.
हाँ, तो उसको बढ़ेगा, बट दैट विल बी इन द पॉजिटिव साइड. उसमें तब कंडीशन अलग हो जाएगा. So in this way, the other examples, that is, we can see the for no dominance, we can calculate the gene frequency due to selection under HoD dominant conditions. So we can calculate. This is one of the calculation. That is, if we in case of that is no dominance conditions, no dominance condition, you will find that is the change of gene frequency due to selection will be minus SQ into 1 minus Q by 1 minus SQ. In case of the change of gene frequency resulting from one generation of selection under no dominance condition is equal to minus SQ into 1 minus Q by 1 minus SQ. So again, you see that is the change of gene frequency due to selection depends upon the two factors. One is the coefficient of selection S, other is the initial gene frequency. In case of over-dominance, you will find the coefficient of selection for A1, A2 and A1 and A2 individuals is different, that is S1 and S2. So that also, that under over-dominance condition also, that is the change of gene frequency depends on the gene frequency, initial gene frequency, both P and Q, and as well as the coefficient of selection of the two genotypes, that is the S1 and S2. Next, we will say this is all about the change of gene frequency due to selection, due to migration, mutation, and selection. That is a systematic process. Now we'll say the change of gene frequency due to dispersive process. That is this. What is dispersive process? The process by which the change of gene frequency in a small population can be predicted only in amount, but not the direction. So as I have said, that is in case of small populations, the change of gene frequency takes place due to sampling of gametes, because that change is random. It is also known as random drift and the genetic drift. What is random drift? The random change of gene frequency in a small population is known as random drift. That means random means that we cannot judge that in which direction the frequency is changing, whether it is in positive direction or negative direction. That means it will always be changing. that's why it is called change is random. That's why it is called random drift. And genetic drift, the change of gene frequency in a small population takes place due to sampling, is known as genetic drift. The change of gene frequency in a small population is erratic in manner from generation to generation with no tendency to revert to its original value. That means, what does it mean? The change of gene frequency in a small population is erratic in manner from generation to generation with no tendency to revert to its original value. That means when we are considering a small population, we draw the sample from each and every time, and you will find that change of frequency of the gene will be changing in a in such a way that is frequency of the two alleles, that is A1 and A2, the frequency of A1 if increases, naturally frequency of A2 will be will decrease in the next generation. And a time will come when frequency of A1 will be 1 in a population and frequency of A2 will be 0. And in another population, the frequency of A2 will be 1, frequency of A1 will be 0. Under that is called from that situations, we cannot revive that a population which will have the frequency of both A1 and A2. That means under that concept we say the genes is fixed in the population, and gene is fixed in the population, and that happens only due to in a small population, and when mating takes place among the individuals within a small populations, there will be inbreeding. So inbreeding increases homozygosity. So that we will see in the next unit, that is unit 3, that is inbreeding and outbreeding. The consequences of inbreeding will discuss in detail. That when population is very small, mating takes place among the individuals within the small population. So there will be every possibility to increase the homozygosity. Considering a locus with two alleles, A1 and A2, so there will be frequency of A1, A2, A1, A1 will be increased, and frequency of A2, A2 will be decreased. Or the frequency of A2, A2 will be increased, frequency of A1, A1 will be decreased. So that means there will be change in the genotype frequency. So, so for this reason, the random drift is also known as genetic drift. So then what is the genetic drift? The change of gene frequency in a small population due to sampling is known as genetic drift. And since the since the direction cannot be predicted, that's why it is the random in nature. That's why the genetic drift is also known as random drift. And the change of gene frequency in a small population due to random drift is determined by the variance of the change of gene frequency. So here is something else, something different to that of the systematic process. In case of systematic process, we have expressed in terms of the delta Q, that is change of gene frequency. But here, in a small population, we have to express in terms of the variance of the delta Q. That is sigma square delta Q is equal to P0 Q0 by 2N. Not given this formula, that is change of gene frequency in a small population due to sampling is expressed as the variance of the change of gene frequency, that is sigma square. Sigma square, you know, it is the symbol of the variance. So sigma square delta Q is equal to P0 Q0 by 2N, where P0 Q0 is the gene frequency of the base population, gene frequency of the A1 and A2 respectively in the base population, and N, capital N, is the total number of individuals in the population. So I have not given in details because here one thing is that suppose a base population is considered initially, or the large population in which the frequency of A1 and A2 allele is P0 and Q0 respectively, and when breeding takes place among the individuals within the locality, that whole population, the large population, will be divided into many subpopulation. The many subpopulation, each subpopulation may be considered as the line. That means there are certain conditions that is for idealized population. Idealized population means when the number of breeding individuals are equal in each and every line and each and every generation. Suppose N is the number of breeding individuals, so that will be constant for each line and in each subsequent generation. So n is the total number of breeding individuals. The total number of genes in a line is equal to 2n. That is gamete. Gene means gamete. Total number of gamete will be multiplied by 2. So in this way, that means breeding will be takes place among the individuals within the population, within the line, and there will be no migration, there is no mutation, there will be no selection. So if and the number of breedable individuals remains constant from for each lines and for generation to generation, then that population is called as idealized population. That population is called idealized population. So this is all. This is all, and just say if you have any doubt, just tell me. Hello, students. So this is all about the change of gene frequency. Now next we shall go for next chapter. And you see the few terms that selection according to I am learner and according to JLS. These two definitions should be at the tip of your tongue. Then other terminology, fitness. Fitness is the contribution of offspring to the next generation is known as fitness of an individual. So हमेशा याद करना that fitness is also known as adaptive value and